So slope fields and Eulers method. We use initial conditions to find particular solutions of differential equations. We use slope fields to approximate solutions of different differential equations. We use Eulers method to approximate solutions of differential equations. So like in example 1, determine whether each function is a solution of the differential equation y double prime plus y equals 0. So I need to figure out the second derivative. Y prime is negative sine of x, because that's the derivative of cosine of x. The second derivative is going to be negative cosine of x. So plug it in. Negative cosine of x plus cosine of x equals 0. Yes, it's a solution. On B, first derivative is going to be negative e to the negative x. Second derivative is going to be negative of a negative e to the negative x, so e to the negative x. Plug it in. That does not equal 0, so not a solution. Next one, c is just a constant, so first derivative is c cosine of x. Second derivative is negative c sine of x. So negative c sine of x plus c sine of x, they're the same but opposite sign, so they do equal 0. That is a solution. On the second one, we want to verify that c e to the negative x squared is a solution, and then find the particular solution determined by the initial condition that when y equals 2 when x equals 0. So first derivative is going to be c times negative 2x, because that's the derivative of negative x squared, times e to the negative x squared, which is negative 2cx e to the negative x squared. Plug that in, so y prime negative 2cx e to the negative x squared plus 2x times c e to the negative x squared. Do a little simplifying. The first, don't have to do any simplifying. The second gets us 2cx e to the negative x squared. They're the same, just opposite signs, so yeah, that is a solution. Y is a solution to it. And now we plug in 2 for y and 0 for x, and so that gets us 2 equals c e to the negative 0 squared, so that's e to the 0, which is 1, so c is 2. So y equals 2 e to the negative x squared. Now here we've got a whole bunch of slope fields. We want to match each slope field with its differential equation. So one of the first things is just kind of look at your powers. And with tech, drawing a slope field by hand is very tedious. That's why you see in this snip I'm not showing a lot, because that's calculating 25 different values for each of these based on what the initial condition is. So a lot of times we'll use a graphic technology like Desmos and plug in our differential to get the equation. Now, why did I say the last one is A? Well, let's plug in a point. Let's plug in 1, 1. If I plug in 1, 2 times 1 is 2, plus 1 is 3. Does that have a slope of 3? Kind of looks like it does. Okay. So that's kind of what we're doing. If I plug in 0, 1, that'd be 2 times 0 is 0, plus 1 is 1. That matches this. This looks like it's got a slope of 1 right there. Okay. Now let's try the next one. That's got a negative, so if I do the same thing here that I had, that should be a negative slope. So that kind of tells me that one's B, because it would be the opposite slope of that one there. And that's true. So that kind of leaves this last one for C. If I plug in 0 for x, no matter what, it's going to be 0. If I plug in 1, that's going to be 2. If I plug in 2, that's going to be 4, because that's what we're plugging in there every single time. Okay. Example 4, sketch the slope field for the differential equation y prime equals 2 plus x for the following points, negative 2, 2, negative 1, 2, and 0, 2. So 2 plus negative 2 is 0, so it's got a slope of 0. That would be this one right here. Plug in negative 1, and that's going to be 1, which is that slope right there. And plug in 0 is 2. That matches that one there. That's what we're looking for in each of those. Okay. Sketch the slope field for example 5 using y minus 3x. Use the slope field to sketch the solution. So I went to Desmos and got it, but we can plug in some values at y prime of 2, 1. That's going to be -5. Okay. That's that point right there, and it's got a slope of -5. That's kind of our initial condition, so that's what we're looking at. That kind of means my slope's going to follow that, and then it's got to come over here, and then somehow it's going to come back down as we go. We're trying to match it, so that's kind of how we follow what those slopes happen to be. Okay. Not the easiest. A little bit of guess and check as we go through. Use Euler's method to approximate the particular solution of the differential equation y prime equals y minus x passing through the point 0, 2. Use 5 steps of h equals 0.1. So y prime equals f of xy. x1 equals x sub 0 plus h. y1 equals y sub 0 plus h times f of x0, y0. So x0, y0 is 0, 2. That's our initial point. And h is 0.1. f of xy is y minus x. So x sub 1 is 0 plus 0.1, which is 0.1. And y sub 1 is 2 plus 0.1 times 2 equals 2.2. X sub 2, just plugging in it as we go through. 2 minus 0 is 2. On this one, 2.2 minus 0.1, because that's what it is. X sub 3, kind of same thing going on. We're just taking the last answers to calculate this part for the y. And we just do it 5 times. So we get this is the approximate solution.